Hello. So this is the project, the hardware accelerator project with the Sobel um, algorithm. So firstly, the part one, which was running the Sobel filter on these three images, the Batman, Joker, Lena, and boat image. This is how long it took for the HPS to run it without the hardware accelerator. Um, So this is just a reference for the hardware accelerator to see how much time it will take. Um, this, these were the output files of the HPS um, running those images, the Sobel filter. So the design was mainly using the high-level synthesis Sobel code that was given to us earlier, as well as our own C code, which was basically um, the main function of the Sobel code that was given to us, and kind of connecting it together with some RTL. Um, the image is just what the platform designer kind of looked like, what kind of PIO pins we used and where their memory addresses were. The results weren't too good. It was more like a hardware decelerator for every image. It took about twice the amount of time to run the algorithm. I'll talk about why that is later, but collectively it took about 48 seconds total to do all three. Um, a code comparison of the two, just to show what we were kind of doing, was this is the original Sobel um, filter on the right, where they kind of just read in the value from well, this is the image, the bitmap. They store it in an array, or really they just have three values and store it. And then it's a global variable, so then they run the Sobel algorithm and then save it. What we did, um, we had specific memory addresses connected to the Sobel filter. So upon every iteration, we would set it, which obviously slows, which is really the main reason for the big slowdown. Um, yeah, so kind of what it's doing, it's this part and this part are the exact same, where it's setting those three input values. The main difference here is this section where it's setting, it's essentially just the clock. It's the positive edge. So we set it to 0, then we set it to 1. So the Sobel filter sees it as a positive edge and runs. So we then retrieve the value and store it to then make the image later, just like the HPS. So that was about it. To show it working, so, well, I guess this is already the result. Let me get rid of this. Yeah. So what I'll do, I'll open up a terminal and go to where we were. let's call it timing.txt again. So what this will do is simply time how long it takes and put it in this file. So firstly, I'll program the FPGA, which we have here. So I'll press start, and as you can see, the screen goes black. It's all zeros. So if I press enter now, we'll start to see these 3 7-segment displays have, I think, the first digit of the 3 inputs. So we'll see them kind of flicker as it's still running. So it should take about 46 seconds or so. So yeah, but I guess as it's running, I'll talk about why it's much slower and how we could make it faster. We could make it faster by doing a block write at the beginning of, but basically just not iterating through the entire image. Because what really slows this down is accessing the memory address through the interconnect. That's the real, I guess, bottleneck in this whole process. And the way that could be done is by implementing some kind of on-chip memory in the FPGA and connecting it through the bus in the platform designer, but I was having trouble doing that, so I ended up doing this. Okay. Seems like it may have finished. Hopefully. Okay, I guess I'll go ahead and stop it. Control C and reset it. So now the screen should come back on eventually. I guess the real takeaway from this project is the interconnect is really slow. It's really what holds back any speed improvement, because actually before doing this, I was accessing more memory addresses than I was currently. Maybe, let's say, 7 more for each iteration, and it would take about 100 seconds for the whole program to run. So the memory, accessing the memory really does hurt the performance quite a bit. Yeah, so yeah, the values are a little different. 0.68 seconds, 0.69 seconds, 47 seconds for the Batman Joker, which is a really big one. But yeah, yeah, that's about it. Okay.